This video is going to show you how you would calculate a resistor or resistance, total resistance in a parallel circuit. Okay, let's get started. Quick review on what a parallel circuit looks like and what a series circuit looks like. Remember, there were two types of circuits. There was the series circuit and then there was the parallel circuit. Okay, so the series looks kind of like a box, you know. Here's one. All right, here's my light. And then here's a switch. You know, this is just your standard series. That is a series circuit. Now let's look at a parallel circuit. Parallel circuit looks kind of like, you know, the same thing except it's parallel. So here's a resistor, and then 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 here's a resistor. Okay, so that's a parallel circuit. That's basically the difference. You know, remember, just to remind you, in a series circuit, current can only flow in one direction. It only has one path to go. And if something happens to any one of these paths, then you are toast. Okay? But in a parallel circuit, it has so many different paths to travel. See, it can go down this row, 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 it can go down blah, 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 blah. Okay, I think you get it. And back. So even if something happened to any of these, boom, 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 it can still travel down these ones. So there we go. Boop, still going down. It still has this path to travel. All right, so that is an advantage of a parallel circuit. Okay, so now, how do you actually calculate the resistance in a parallel circuit? All right, well, using the formula for parallel circuits, you would have this. R is R total plus, oh, excuse me, not plus, equals 1 over R1, you know, plus 1 over R2, plus 1 over R3. All right, and that's actually how you would calculate the total in a parallel circuit. Now, this is nice if you like fractions and you want to do the least common denominator of stuff, you know. Remember this 1 over 4 plus 1 over 2. What's the least, you know, you have to figure out, get these down here the same. So this would be, you know, this times 2 and this times 2. So now you have 2/4 and now you can add them. So, you know, blah, blah, blah. 2 plus 1 equals 3 and this is 4 if you're into that kind of stuff. But if you're not into that kind of stuff like me, I hate this stuff. I hate fractions with a passion. I hate them. I hate them. I hate them. I hate them. If you are not into that kind of stuff, then I have a whole nother way for you. Okay? It's all about the decimals, baby. And adding. Who likes to add decimals? I do, because they're so easy. So let's do that way instead, okay? First off, let's start with a actual, let me just draw a quick parallel circuit. All right, so in this picture, you have a parallel circuit, and you have this formula for parallel circuits. So how would you actually calculate the total resistance? Total resistance, all right? You would use this formula. So R1, 1 over R1, plus 1 over R2, plus 1 over R3. This is how you would do it. You would actually just plug these in. Okay, so 1 over, this could be your R1, this could be your R2, this could be your R3. It doesn't matter what order, just make sure you plug them in. So let's do it. So 1 over 4 ohms plus, let's see here, 1 over 2 ohms plus 1 over 3 ohms. All right, so now, if you're into decimal or into fractions, then you can go right ahead and try to make all of these decimals, or, you know, not decimals, denominators the same. But again, if you're not into that, this is what I would do. I would just take each one by one and convert them to a decimal. So in your calculator, you would punch in the 1 first and then divide it by the 4. You should get a 0.25. And no, you don't have to put the 0 there. I just do because it looks prettier. All right? So 0.25 plus, and then you would take this one, 1 divided by 2. Put the 1 in first, divide by 2. You should get 0.5. All right? And no, you don't have to put this 0. I just do it because I like things to be even. All right. So then you have this one, 1 divided by 3. Uh-oh. sorry, 1 divided by 3, and you should get 0.33. Okay, and then you add these. Easy, much easier. Okay, so I've added them up, and I ended up with a 1.8. Now, what do you do with this 1.8 number? 1.08, excuse me. You take this 1.08 and you put it over here. See, look, remember where it says 1, let me just get my thingamabob over here. Okay, so you see how it says 1 over R1, 1 over R2, and 1 divided by R3? All right, so now this is my R total. So I would put this R total, and I would stick it underneath this 1. So I got so much going on, I'm going to go to the next page if that's okay. So now you would take your 1 over 1.08, and then you would divide it. So you just go 1 divided by 1.08 in your calculator, and you should end up with 0.93. There you go. And that is my total resistance for that circuit. Okay? It's that simple. Maybe that confused you. We'll try another one. Here's my new parallel circuit. So here we go. I have R1, here's R2, here's R3, and here is R4. That means I got 4 different resistors. Yes, the lights count as resistors because remember, they're using electricity. So how would I do that? Remember, 1 over R total, okay, equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on, so on. And in this case, I happen to have 4 of them. So I would set it up like this, all right? I would go 1, I'm just going to, I like to just do everything like that. Okay, and I'm going to just add these just to make it pretty. All right, and this is my equals, remember? All right. All right, so now I have it all, and it's beautiful. So 1 over 10, because that's this one. And then 1 over 3. And then 1 over 8. And then 1 over 20. Okay? And then, what do you do next? You break them down into decimal form. So, we're going to start with this one first. 1 divided by 10 is going to give me 0.10. All right, 1 divided by 3 is going to give me 0.33. This is all plus. 1 divided by 8 is going to give me 0.125. And 1 divided by 20 is going to give me 0.05. Now, if I was to total all these up, I would get 0.605. All right? Oops, there's my point. 0.605. Those of you who like that 0.605. Now, what do I do with this number? I plug it in right here. So now I have 1 divided by 0.605. And then I take this number and I stick it in my calculator. 1 divided by 0.605. And I get equals, use a different color, 1.65. And my total, that is my total resistance for this circuit. Yay. Okay. Now you try. Copy this down in your book and then give it a shot. Pause it. I'm going to pause it now, or I want you to pause it now, and try to solve it. Now I'm going to go ahead and just solve it quickly. You could do it like this. You could write them all out like this in fraction form, or you can skip this completely and just know that all of these are over 1, and then just change them into decimal form automatically. I'll give you an example. So you just know this is 1 divided by 10. So you have 0.5, or not 0.5, 0.10 plus 0.2 plus 0.1 plus 0.2 plus 0.33, because the 33 is this one. You add them all up. It equals 0.93. And of course, remember, you always want to be labeling. Okay, and now we're not done yet because we need to put this answer over 1. So we put it in our calculator. 1 divided by 0.93. And you get 1.07 ohms. Yeah, and we're done. Under 10 minutes.